Okay, good evening, everyone. Welcome to IAS Origin. This is Anubhav Deepani, faculty at IAS Origin. Today, we are going to discuss a very important topic related to your geography, which is going to be very, very important for your prelims examination also. As we all know that geography and environment and ecology are kind of a cousin subject. And if you are very good with your geography, you will be also very good with your environment and ecology subject also. Now, there are many topics in geography GS which are kind of very, very complicated and they are completely conceptual topic as we know them. Most of the topics are actually conceptual. Few of the topics are actually factual also in geography, and in which you have to mug a few of the things. But there are two most important topics in geomorphology, that is world physical geography, that is endogenic and exogenic forces. I hope all the aspirants who have been preparing for the UPSC civil services examination, they might be aware about the major syllabus category of geography GS, that is geomorphology, climatology and oceanography, Indian physical settings, and human geography and mapping. But today we would be studying about world physical geography, and in that particular scenario also we would be studying endogenic forces in detail. And one of the endogenic forces we would be studying today, that is basically the converging forces, in which we would be studying two type of physical features, that is fold mountain and volcanic eruption. First of all, please understand this fact that if you need to study geomorphology, so first of all, you need to have this basic concept at a very clear level that this is what we call interior structure of the earth. See, whenever we need to study about geomorphology, interior structure of the earth is very, very necessary. Just try to imagine right now where you are sitting or right now where you are standing. That is basically you're standing on the mean sea level. That is you're standing on the 0 kilometer. That is the surface of the earth. But if you basically go 60 kilometer deep down the earth, so this 0 to 60 kilometer is basically known as crust. And after that, if you basically go 2900 kilometer deep, this is basically known as what? Mantle. And then from 2900 kilometer to 6370 kilometer, this particular depth is basically known as core. Now, how we actually decided that this is going to be the interior structure of the earth? We actually decided this particular scenario through the study of minerals, because as we go deep down to the earth, we actually found different type of minerals, such as Sial, that is silica and aluminium. Then there is Sema, that is silica and magnesium, and then there is Nife, that is nickel and iron. So this is a kind of an interior structure through the mechanism of the minerals only. But there is one more categorization of the interior structure of the earth, which is known as mechanical layers. Now, when we study the mechanical layers completely, after that only you will be able to understand that what do you actually mean by endogenic forces. Now, please try to understand, guys. Where you are standing or where you are sitting right now, that is basically known as a 0 kilometer. But after 0 kilometer, if you go down to 100 kilometer, so this particular depth of 0 kilometer to 100 kilometer is basically known as a lithosphere. And then after that, if you go 100 to 400 kilometer, this particular depth is basically known as asthenosphere. Now, please try to understand this point. Is lithosphere, that is 0 to 100 kilometer, is completely solid and it is basically completely brittle. And this asthenosphere is what we know as semi-solid or semi-liquid. Now, what do you mean by semi-solid and semi-liquid? You need to imagine any kind of material at your place which is kind of not solid also and not liquid also, somewhere in between. Like for example, if you talk about toothpaste, or if you talk about any gel, or if you talk about any tube or grease which we basically use in automobiles, so that is what we call basically semi solid or semi liquid. Now please try to imagine here that the depth of the earth, that is 0 to 100 kilometer, that is lithosphere, that is solid, and that is very, very brittle. But if you basically go deep down from 100 to 400 kilometer, that is known as a semi-solid or semi-liquid. So here, please look at my hand here and please try to imagine that this upper hand is basically your lithosphere and this lower hand is asthenosphere. So lithosphere is completely dependent on asthenosphere here right now. And if your brittle portion is somewhere on this particular semi-solid or semi-liquid categorization or plate. So this brittle portion will be completely floating over the semi-liquid portion. That means this particular lithosphere will be floating over the asthenosphere. Now please understand, whenever we are walking on the road, we do not slip. Why? Because the road which we are walking on or upon, that is also solid and brittle, and our legs are also solid and brittle. So there is basically frictional force between both the solid between both of the solid plates. There is friction, that's why we don't slip. But here please look at this thing, that lithosphere is solid but asthenosphere is not solid. Asthenosphere is semi solid or semi liquid. That means when the lithosphere is completely there over the asthenosphere, there is lack of friction, and when there is lack of friction, this lithosphere will float over asthenosphere. It is as simple as that. Now, if this lithosphere is floating over asthenosphere, this is one concept where we are very, very clear. What do you think? That is lithosphere completely blank from inside? Is lithosphere completely empty from inside? No, that is not the scenario. From 0 to 100 kilometer, the whole depth of lithosphere which you see here, please note, imagine here that this is your lithosphere here, and underneath lithosphere, this is your asthenosphere here. So if your lithosphere is completely floating over the asthenosphere, this 100 kilometer of plate is basically floating here. So this lithosphere portion is not empty here. Two types of plates are there inside the lithosphere, and these two plates are known as continental plate, and they are also known as oceanic plate. Now, what do you mean by continental and oceanic plate? Please understand this. If any plate is made up of granite, if any plate is made up of granite, that is basically known as continental plate. And if there is any plate which is made up of basalt, that is basically known as oceanic plate. So there are two types of plates floating or moving under the lithosphere, and when these two plates move alongside, this is basically what we know as plate tectonic. And because of these plate tectonics, we see many types of physical features on the surface of the earth. And this is that particular concept or point where we come across of another concept, that is the endogenic forces or the exogenic forces. Please try to understand the difference between endogenic and exogenic forces. The forces which are basically working under the surface of the earth, inside the surface of the earth, those forces are known as endogenic force. Number one. Number two, exogenic forces are actually those forces which are working outside the surface of the earth. Outside the surface of the earth. Inside the surface of the earth, endogenic forces are working. It actually means that for example, convergence of the plate boundaries, divergence of the plate boundaries, or transverse boundaries of the plate boundaries. So first of all, let us understand the endogenic forces which are working. Just a minute. Just a minute, please. Yes. So which are working under the surface of the earth. Let's understand this way. Now there are total three types of endogenic forces. Number one is the converging boundaries. Number one is the converging boundaries. Number two is the diverging boundaries. And number three is the transverse boundaries. Let's understand all of these three plate tectonics. There are two types of plates inside the lithosphere, that is the continental plate and the oceanic plate. Now, if these plates are continuously moving, so there will be chances here that these two plates will be basically coming to each other and will be attacking each other. This is what we call converging boundaries. When two plates are coming to each other or getting assembled together or becoming basically a one plate. Number two is the diverging boundaries. Diverging boundaries means that there is only one plate here and one plate is being broken down from the middle, and this one plate is getting divided into two different plates. So this is basically your diverging boundaries. And third type of boundary is basically that kind of scenario where two plates are moving parallelly along with, they are basically touching each other, they are actually kind of cracking each other also, but they are not in contact 100%. So this is what we call your transverse boundaries. Now please understand this scenario. If this is your one plate and if this is your second plate, okay, so if these plates are coming together like this, so this is what we call converging boundaries. Or suppose in diverging boundaries, if this is one plate and it is being broken down from the middle and these plates are basically moving away from each other, this is what we call diverging boundaries. And in the transverse boundaries, please imagine that two plates are moving parallel to each other, but they are not in contact completely. This is what we call endogenic forces. Now, if you are talking about the converging boundaries here, so converging boundaries could be actually of three different types. Number one, that continental plate will be there with the another continental plate. Or number two, oceanic plate will be converging with another oceanic plate. And then continental plate will be converging with another oceanic plate. And then in diverging, there will be just two scenarios. That is continental plate being broken down into two plates and then oceanic plate being broken down into two different plates. So studying these concept of converging boundaries and diverging boundaries, this is basically known as your endogenic forces, and this is also known as continental plates. Now please try to understand one more thing here. When we are talking about the converging plates actually come as a result of different physical features, which are known as fold mountain, block mountains. They are known as volcanic eruption. They give you the result of earthquake. They give you the result of tsunami. They give you the result of ocean bottom topography, etc., etc. So each and every physical feature which you see on the surface of the earth, that is only and only because of the converging boundaries. But the physical features which are basically built by the converging boundaries or by the endogenic forces, they are being eroded, or the weathering is done, or the erosion is done by the erosional agents. Like for example, river is basically one of the major agent of erosional forces. Like for example, let's say if this slope, just imagine that this hand of mine is basically a slope of Himalaya mountain here. Now, if these two fingers are basically Ganga River, so Ganga River is getting originated from the Himalaya. So this Ganga River will be having two different banks. eastern side and western side. So these banks will be breaking down the small stones and pebbles and etc things from the Himalayan mountain here, and they will be doing the weathering and erosion. So if the height of Himalaya has been increased because of the endogenic forces or because of the plate tectonics, the same height or length or the whole physical feature of Himalaya will be basically decreased or degraded by the erosional forces. So that is what we call exogenic forces. Besides river, there is one more agent which is glacials. Then there is a karst topography, that is underground water. Then there is coastal waves or sea waves, and then there is wind also. So there are total 5 different major erosional or exogenic forces agents which do the weathering or erosion of the physical features on the surface of the earth. Now we will study how these converging boundaries are basically making different types of physical features. We will be taking example of 2 different physical features right now today. One will be the fold mountain and another will be the volcanic mountain and volcanic plateau. Just give me a minute, please. Just a minute. So here, please understand, whenever we are talking about the endogenic forces, first of all, let's have a discussion about the converging boundaries. About the converging boundaries. Okay. Now, in converging boundaries, let's just imagine one thing here, that you have, this is your 0 kilometer, or this is basically your mean sea level. Okay, mean sea level or 0 kilometer, where we are residing right now, where we are sitting or standing right now. That is basically our land surface. That is what we call mean sea level or MSL or 0 kilometer or earth surface. Now inside this particular mean sea level, let's imagine 2 plates are there. One is your continental plate here and the other one is your continental plate here. Now, if these 2 continental plates will be coming together, so this will be basically known as the converging boundaries, because 2 plates are coming with each other. Now, please imagine if these 2 hands of mine are basically the 2 continental plates. So you can basically do it where you are sitting also right now. Just put your hand on any of the platform or your table or your desk and just try to push these 2 hands closer to each other. So what will you basically witness here? You will witness here that both of these hands or both of these plates will go upward side. That means these plates were kind of horizontal, and when they attack each other, they will be folding each other and will be converted into kind of a vertical plate. So these plates are being folded here. So this is what we call fold mountain. So this mountain will be basically constructed like this, and this is what we call fold mountain. And this fold mountain is created when 2 continental plates come together. Okay. Now there are many examples of fold mountains in the world. The best example is the Himalayan mountain, because Himalaya mountain is the youngest fold mountain of the world. Okay. Himalaya is the youngest fold mountain in the world. That means Himalaya is only and only 70 million years old. I know this time scale is too much, but in geography, 70 million years old is actually nothing. It is actually very young. Now, if you basically categorize Himalaya according to the fold mountain theory, you will basically see that Himalaya also is divided into 4 different ranges. Like, for example, these are basically the 4 ranges of Himalaya. Number 1, number 2, number 3, and number 4. Now the northernmost Himalayan range is your Trans Himalaya. That means Himalaya is the youngest fold mountain, but in Himalaya also Trans Himalaya is the oldest range. And after that, the second range of Himalaya you will see as Greater Himalaya. Then the third range you will see as Middle Himalaya or Himachal Himalaya, or the fourth range you will basically also see as Shivalik. Now you please notice one thing. This Middle Himalaya, Himachal Himalaya or Shivalik is there in the region of Uttarakhand. It is there in the region of Himachal Pradesh, Nepal, Bhutan, and some of the portion of northeastern Himalaya also. That's why we basically see the earthquake kind of incidents in these particular states. You will basically never see earthquake kind of scenario in Ladakh region. Why? Because the Ladakh region is basically at the range of Trans Himalaya, and in the region of Trans Himalaya, the plates, the two continental plates have stopped moving. Now if it is being asked in your prelims examination that because of which two continental plates Himalaya was formed, so you will answer what? There are two plates. Number one is the Indo-China plate, also known as the Indo-Austral plate, and second one is the Eurasian plate. Now because of these two plates you will see here that Himalaya was basically being formed. And now these two plates are not having any kind of activity in the Trans-Himalayan region. That's why if there is no activity of the plate tectonics there in the Trans-Himalaya, there will be no activity of earthquake also. And the same scenario is in the region of the Greater Himalaya also. But if you basically go to the Middle Himalaya, if you also go to the Shivalik Himalaya, that these two plates, that is Indo-China plate and the Eurasian plates, are still active here. That's why we see the conditions of earthquake in Himachal Pradesh, in Uttarakhand, sometimes in Nepal also, and in Bhutan also, and in some of the scenario in northeastern India also. So this is the way where through these two continental plates convergence, we basically see happening of fold mounting. Okay, now let us go to the second scenario here. Now let us take this 0 kilometer and mean sea level again, and if you basically see two different plates having convergence with each other, let's say continental plate at one side and oceanic plate at other side, and these two plates are actually having the convergence here. But now these two plates will not be basically making the fold mountain here, because your continental plate is made up of granite and your oceanic plate is made up of basalt. Now we all know that the density of basalt is higher than the density of granite. So what is going to happen here is that whenever there will be convergence between the continental and oceanic plate, the oceanic plate will be submerging under the continental plate here, because the plate which is having more density will go under the lighter plate, or it will be submerged under the lighter plate. Now please understand one more thing here. This oceanic plate's length is too much. It's very high, it's very huge, and this oceanic plate width is also very high. So here you basically see that the oceanic plate, inside this oceanic plate there are many different kind of minerals like iron or manganese or nickel or copper, etc, etc. So these minerals are there somewhere in the solid form, but when this oceanic plate goes in under the continental plate or gets submerged under the continental plate, these oceanic plates are basically converted into liquid form. These are converted into liquid form. Now why the minerals of oceanic plates are basically getting converted into liquid form? Because of the two reasons. Reason number one is that when you go 1 kilometer inside the earth, the temperature increases by 1 degree Celsius. Why? Because radioactive minerals are there inside the earth, such as uranium, thorium, or sulfur. Okay, so when you basically go 1 kilometer inside the earth, temperature of earth Earth will be increased by 1 degree Celsius. And because of that temperature, oceanic plates solid minerals are converted into liquid minerals. Number one. Number two, when this oceanic plate is basically submerging under the continental plate, the kind of weight or pressure which continental plate is putting over the oceanic plate, because of that also the temperature also increases of the oceanic plate mineral. And finally, these minerals of oceanic plate are converted, they are converted into molten rock. And when they are converted into molten rock, they are known as magma. Okay, they are basically known as magma. Now when the magma is created here, obviously it will basically originate warm air also and warm liquid also. And this is a very basic phenomena of geography and physics also, that any warm liquid or any warm air or wind or any warm thing tries to rises up. So here in this scenario also, this magma will basically try to go up here, and whenever it will be finding any kind of small crack at the 0 kilometer or earth surface, this whole magma will come out of the earth surface. And as soon this magma will come out of this earth surface, it will be basically known as what? It will be known as lava. Now please understand one more thing here. When the lava comes out of the earth surface, this is basically known as what? This is known as volcanic eruption. Now the volcanic eruption has happened here. Volcanic eruption is there in the scenario. Now there can be two different physical features which can be created because of the volcanic eruption here. Number one is the volcanic plateau and number two is the volcanic mountain. Now just understand this point, that the lava which has basically come out of the surface, imagine the silica, the quantity of silica is very high, the quantity of silica is very high here. So the viscosity, that is what we say in Hindi, gadhapan. So viscosity of this lava will also be very very high. And if the viscosity of lava is very high, so this particular lava will not spread that much. That means this particular lava will be getting deposited over and over here. So this lava will take the shape of this particular formation. And as you can see here, it is basically taking the shape of a mountain. And this mountain is basically known as what? Volcanic mountain. Now please understand one more thing here. If the volcanic eruption has happened just once, so why the volcanic eruption will be happening there at the same time again and again? Just look at my hands and try to imagine. Just imagine this particular hand of mine from finger to elbow. Suppose this is the oceanic plate in the lithosphere. Okay. And this oceanic plate is being submerged under the continental plate. So this portion, the hand where I'm moving my hand, this particular portion of oceanic plate will be basically converted into a molten rock. Okay, so this will be basically coming out of the surface in the name of lava. But the movement of oceanic plate has not stopped it yet. So this movement will be continuously it will be going under this continental plate, and it will be submerging. Fair enough. So once the submerging thing has done or has been completed, volcanic eruption will be there at the first time, then the submergence will be there another in the second stance, then there will be again molten rock, then there will be lava in the third time, fourth time, fifth time, and it will be going on and on and on until and unless you don't see the whole of the volcanic mountain there, or until and unless you don't see that the complete or the whole oceanic plate has been submerged under the continental plate. So this is basically the another concept of active or not active volcano. So whenever you basically see that if there is any volcano which is kind of active, or from the mouth of that particular mountain which is also known as crater. So if you see lava coming out of crater, so you need to understand that that particular lava coming out of the crater is the active volcano. And why that active volcano is going on? Because the oceanic plate is still active there in the lithosphere, and that oceanic plate is going under the continental plate. But what if the oceanic plate is completely submerged under the continental plate? And how will you get to know that that particular lava is not active anymore? You will get to know in a kind of a monsoon situation, that if there is a crater, like for example, this is your crater, this mouth of this volcanic mountain is known as what? Crater. So if this is your crater here, so suppose if there is a rainfall or monsoon going on in that particular region, so the rainfall water will be deposited in the crater. If this volcanic mountain was kind of an active volcano, so the temperature inside that particular volcano obviously would have been more than 100 degrees Celsius. So the evaporation of that particular water would have done or would have happened. But here, if you see that the rainfall water is, if it is deposited there in the crater, and the evaporation of that particular water is not happening, that means the temperature inside that volcanic mountain is not more than 100 degrees Celsius. So that particular crater will be full of water, and that will be the creation of a lake, and that will be known as crater lake. So whenever you see the formation of crater lake, you need to understand, or you need to get this concept, that that particular volcano is not active anymore. You can see the example of a crater lake in Maharashtra in India. There is one Lonar crater lake. So that means at one point of time there was active volcano there, but right now the active volcano is not there. But you can basically come for the second scenario also. There is one more situation here. Now, please understand what is the another situation here. Another situation is very, very easy here. Just imagine the same kind of volcanic eruption is going on. Oceanic plate is going under the continental plate. Okay. And if you basically see, let's do one thing. Let's make this diagram again. Okay. So this is again your 0 kilometer, and this is your mean sea level. This is your continental plate, and this is your oceanic plate. And this oceanic plate is being submerged under the continental plate. Molten rock is here, so it is being converted into liquid. And here then you see that the magma has come out of the surface. Magma has come out of the surface, and this is basically your lava or volcanic eruption. Now let us do one thing. Let us flip the situation. In the volcanic mountain scenario, we saw that the quantity of silica is very high. So let us do one thing, that if in the lava the quantity of silica is very, very low, so the viscosity of that particular silica will also be very, very low. That means this particular lava will spread a lot. That means this particular lava will not be deposited at one point. So it will be spreaded, and when it will be spreaded, it will not create the physical feature of a volcanic mountain, but it will create the physical feature of volcanic plateau. Okay, you can basically see the example of volcanic plateau in India in complete Deccan Trap, that is whole of the Maharashtra, whole of the Gujarat, and the Malwa Plateau. Malwa Plateau is basically the western Madhya Pradesh. Now you basically see the formation of Maharashtra, Gujarat, and western Madhya Pradesh as the volcanic plateau only. Now let us do one more thing. If the volcanic plateau is there created in the western side of India, so erosional forces agents will also be working there. Like we just understood 10 minutes ago, that when the Ganga river is getting originated from Himalaya, and Ganga is doing the weathering and erosion, by degrading Himalaya's height or by breaking down the small pebbles of Himalaya. So the kind of erosion Ganga was doing with the Himalaya, the same type of erosion Narmada river can also do with this particular volcanic plateau or Deccan Trap, because Narmada river gets originated from the eastern Madhya Pradesh, from Amarkantak plateau. It basically crosses whole of the central Madhya Pradesh, touches the Maharashtra border, goes to the western Madhya Pradesh, enters into Gujarat, and finally falls into Arabian Sea or Bay of Khambhat. So the same kind of erosion, the same kind of weathering, Narmada River will also be doing while it will be flowing over the volcanic plateau or Deccan Trap. So this volcanic plateau or Deccan Trap, because of the Narmada River, will be basically converted into these small pebbles, and these small pebbles erosion will be basically known as what? It will be known as soil. So soil formation will be done because of this erosion. And which soil erosion will be done here? That is the black soil here. That's why you see black soil in whole of the Maharashtra, Gujarat and Western Madhya Pradesh. Now this particular erosional thing is now directly connected to the agriculture of India. Now we all know that wherever we see black soil, wherever we basically see black soil, we see that the maximum agriculture is there of cotton. We see the cropping pattern of cotton plus potato, sugarcane, groundnut, tobacco, etc. You will see sugarcane cropping pattern in alluvial soil also. You will see cotton in alluvial soil also. And there is tobacco in the black soil, but you will see tobacco in the red soil also in Andhra Pradesh and Telangana region. But for cotton production, black soil is the best soil, not just in India, but in whole of the world. That's why this particular black soil is also known as cotton soil or Regur soil. So this is how interesting geography is, because when you start studying your physical geography, you need to do the transformation from physical geography to human geography. And when you basically understand how to connect physical and human geography, you will become the expert of geography here. So this endogenic and exogenic forces, which we studied here with the two different examples of converging boundaries and diverging boundaries of volcanic eruption and fold mountain, continental plates, etc. This is going to be very, very important for your prelims examination. So this is how we basically teach in IAS Origin, where we take the topic from the basic zero level and we basically take you to the advanced level. Now, if you basically want to join IAS Origin and want to make your UPSC Civil Services examination journey much easier and you want to create higher chances of clearing this examination, so IAS Origin is coming up with their new batch on 27th of May, where you will be getting the free demo classes for at least 2 to 3 days, and then you will be registering yourself and you will be getting the live classes for prelims and mains examination and unlimited recorded access. Now let us uh, discuss this it in a bit detail. IAS Origin is basically providing you three types of courses. Please understand this. Now, IAS Origin has three different batches, which are basically known as the bronze batch, silver batch, and the gold batch. Now, what is the difference between the bronze, silver, and gold batch? Let's understand this thing. Okay. Now, please look at the price of bronze batch here, which is 27,000 rupees. The price of silver batch is 43,200 rupees, and gold batch is here of 72,000 rupees. Okay, if you are not basically able to pay this much of amount at once, so there is one more option for you, that is the monthly EMI option. If you want to go for the bronze batch, you have to pay 3,000 rupees per month. If you want to go for the silver batch, you just need to pay 4,800 rupees per month. And for the gold batch, you need to pay 8,000 rupees per month. Now, let us please understand that what is the difference between all of these three batches. Let's say if you join the bronze batch of IAS Origin, in that you will basically get the general studies, prelims and mains live classes daily. Besides that, you will get the unlimited recorded access. For example, in any of the day, if you were not available for attending the classes and you missed any lecture, so you can basically get the recorded access of all the live lectures, and that will be completely unlimited. That means you can watch those lectures once, twice, thrice, 10 times, 50 times, 100 times. It completely depends on you, and you can do the revision with that also. Besides that, there will be unlimited doubt resolution, but it will be through only email in the bronze batch. Besides that, there will be answer writing session by the experts, daily current affair PDF, CSET classes, economic survey classes, budget classes, and group discussion between the students also, among the students also. I'm so sorry. But which is best of the best batch for IAS Origin? Personally, my favorite two batches are your silver and gold batches. Please try to understand why. See, in silver batch, you will be getting everything which you got in the bronze batch. But in your silver batch, you will be getting one more interesting thing here, which is your prelims weekly test series with your solution, mains weekly test series with a solution, and the most important thing, that is GS hard copy study material. Guys, IS Origin is the only online platform in which if you join and study online, even then we will not be giving you all the notes in soft copy, but we will be giving you the notes in hard copy. That means there will be more than 15 booklets of 18 modules of all the subjects, and those modules or hard copy materials will be couriered to your home address or permanent address. That means those hard copy materials will be sent to you. Besides that, the most important thing about this silver badge is your personalized timetable, and you will get a mentor also. We see many of the aspirants in this ecosystem of UPSC civil services examination, that many of the aspirants are actually college going students, or there are some people who are doing their job also and they are not able to manage their time. So what IS Origin is going to do for you is that we are going to provide you a mentor who will be an expert subject expert, and that particular mentor, with the help of other mentors and faculty, will be asking your daily routine, will be analyzing your daily routine, and according to your daily routine we would be basically making a perfect timetable for you, where you can basically manage at least studying of a 5 to 6 hours besides your live classes. But this particular personalized timetable and mentoring thing is available for the silver batch. It is not available for the bronze batch. But if you want the maximum of the facility, you need to go for the gold batch. Because when we come to the doubt resolution scenario, in bronze batch your doubts are only and only solved through email, but in your silver batch it will be solved through email and WhatsApp. But let us come here and look at this. If you join IS Origin Gold batch, your doubt resolution will be there through emails, through WhatsApp, through phone calls, and through Zoom video call. Let's just take an example that if you are basically studying a live class in the morning session from 9 a.m. to 11 a.m., and if you are revising that particular session and notes in the evening, and at 6 p.m. you basically get a doubt, and you basically want your faculty with whom you basically completed that particular topic, you want your faculty to clear your doubts or doubt resolution scenario. So you just need to contact your mentor, and mentor will be connecting you with the IS Origin faculty. For example, if I am teaching you polity or geography, and if you have any kind of doubts related to the topic of polity and geography, so you can directly be connected to me through Zoom video call. So the faculty who is teaching you will be solving your doubt. And this is a kind of a very unique aspect of IS Origin. Besides that, you will be getting each and everything in the gold batch, which you got in silver batch, but there will be some of the different facilities also. Like for example, you will get the topper sessions. That means the candidates who have already cleared this particular civil services examination, they will be giving you the guidance. Individual student strategy will be there, and one-to-one mentorship will be there. So if you basically want to join IS Origin, and if you like this platform, and if you want to check more on this platform, so let me just tell you 2 3 more things important. Number one, IS Origin will be having a 3 hours long workshop on UPSC Civil Services examination about how you should basically prepare for this examination, what should be the perfect strategy. And this workshop will be there on Sunday by IS Origin, and I will be taking that workshop with you live. For all that particular information, just go to the link given in your description, and there is official number of IAS Origin. You can contact in that number, and that workshop is going to be very, very free for you. You just need to call or message on that particular number, need to book your seat. Besides that, when you basically attend our workshop and you are interested in joining IAS Origin and you just want to see how faculties basically teach you, so we basically give you the 3 days prime access to our live batches. We give you the 3 days demo classes, in which if you want the demo class in complete English, that will also be provided. And if you want 3 days Hindi medium demo, that will also be provided. So number one, do attend the workshop. Number two, please go for the demo classes. Call on the IAS Origin official number. Give them your daily routine. Ask them the strategy. They will be making the timetable for you. And if you want, and if you believe that IAS Origin can make your journey easier of this UPSC Civil Services examination, join as soon as possible. Okay? And please, the most important thing, go in the description and you will basically see a link there, and 3-hour free workshop classes is there. Okay, 3-hour workshop classes will be there every Sunday. So next Sunday it will be there from 12 p.m. to 3 p.m. I'll see you there. I will tell you the detailed strategy, and I will basically solve each and every doubt of yours related to GS prelims, CSAT, current affairs, how to choose optional, how to do answer writing, what kind of things you need to take care while writing your GS paper 4 and essay writing. Many of the students are very confused related to the language paper. They are just qualifying in the mains examination, but even then they are very, very important. Language paper of mains examination are as important as the CSAT examination of the prelims. So I will be solving the doubts related to each and everything. Attending that particular workshop of Sunday IAS Origin 12 p.m. to 3 p.m. is must for you. Just go in the link given in the description, and whole of the detailings will be there in front of you. There will be official number of IAS Origin. Do contact there also. Join IAS Origin as soon as possible to make your dream of clearing this UPSC examination in a practical way successful. Thank you so much. I'll see you very soon in the next video. Hope to see you soon in the live batches also. Thank you.